For any rectangle ABCD, decide whether this statement is always or sometimes true. Explain your reasoning. Part A. AB equals BC. Look at a sketch of a rectangle ABCD, and AB is equal to BC. So AB equals BC when ABCD is a square, because squares have 4 congruent sides. But not all rectangles are squares. So this statement is sometimes true. Part B. AB equals CD. Again, look at a sketch of a rectangle ABCD. A rectangle is a parallelogram by definition. Then by the parallelogram opposite sides theorem, opposite sides of a parallelogram are congruent. So this statement is always true. Classify the special quadrilateral. Explain your reasoning. The figure is a rhombus. 2 pairs of opposite sides are parallel, so by definition the figure is a parallelogram. By the parallelogram opposite sides theorem, opposite sides of a parallelogram are congruent. The figure has 2 adjacent sides congruent, so by the transitive property of congruence, all 4 sides are congruent, which by definition makes this figure a rhombus. Use the diagram. Find the measure of angle ABC and the measure of angle ACB in rhombus ABCD. Looking at the diagram, the measure of angle ACD equals the measure of angle 2 because angle ACD and angle 2 are alternate interior angles because they lie on opposite sides of the transversal and inside the parallel lines. Because by definition, a rhombus has 2 pairs of parallel lines. So the measure of angle 2 equals 61 degrees. And the measure of angle 3 equals 61 degrees because the diagonals of a rhombus bisect the angles. So the measure of angle 3 equals the measure of angle 2. And the measure of angle 1 equals 90 degrees because the diagonals of a rhombus are perpendicular. Then by the triangle sum theorem, the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Substituting in the known values gives 90 degrees plus 61 degrees plus the measure of angle 4 equals 180 degrees. Simplifying on the left side gives 151 degrees plus the measure of angle 4 equals 180 degrees. Subtracting 151 degrees from each side gives the measure of angle 4 equals 29 degrees. The measure of angle ABC equals 2 times the measure of angle 4, because in a rhombus opposite angles are congruent and the diagonal bisects the angle. So substituting in 29 degrees for the measure of angle 4 gives 2 times 29 degrees, which gives the measure of angle ABC equals 58 degrees. The measure of angle ACB equals the measure of angle ACD because the diagonals of a rhombus bisect the angles. Substitute 61 degrees for the measure of angle ACD. So the measure of angle ABC equals 58 degrees and the measure of angle ACB equals 61 degrees. Use the diagram. Suppose you measure one angle of the window opening and its measure is 90 degrees. Can you conclude that the shape of the opening is a rectangle? Explain. Let this angle be the angle that you measure, and the measure is 90 degrees. Yes, you can conclude that the opening is a rectangle. Both pairs of opposite sides are congruent. So the opening is a parallelogram by the parallelogram opposite sides converse. By the parallelogram opposite angles theorem, opposite angles are congruent. So because you measured one angle and it's 90 degrees, the angle opposite to it is also 90 degrees. Then by the parallelogram consecutive angles theorem, consecutive angles are supplementary. So the consecutive angles are also 90 degrees because 90 degrees plus 90 degrees equals 180 degrees, which is the definition of supplementary angles. A parallelogram with 4 right angles is a rectangle. So you found that you have 4 90-degree angles, so you can conclude that the window opening is indeed a rectangle. In In rectangle ABCD, AC equals 7x minus 15 and BD equals 2x plus 25. Find the lengths of the diagonals of ABCD. By the rectangle diagonals theorem, the diagonals of a rectangle are congruent. So AC equals BD. Substitute the known values into the equation, which gives 7x minus 15 equals 2x plus 25. Subtracting 2x from each side gives 5x minus 15 equals 25. Adding 15 to each side gives 5x equals 40. Dividing by 5 on each side gives x equals 8. When x equals 8, AC equals 7 times 8 minus 15, which equals 56 minus 15, which equals 41. And BD equals 2 times 8 plus 25, which equals 16 plus 25, which equals 41. So the length of the diagonals is 41 units. Decide whether parallelogram ABCD with vertices A negative 2, 3, B 2, 2, C 1 negative 2, and D negative 3 negative 1 is a rectangle, a rhombus, or a square. Give all names that apply. Begin by graphing your parallelogram. Start with points A negative 2, 3, B 2, 2, C1 negative 2, and D negative 3 negative 1. Then connect the points using line segments. Find the distances of the diagonals. If the diagonals are congruent, then you know that the parallelogram is either a rectangle or a square. First, look at line segment AC. AC equals the square root of the quantity negative 2 minus 1 squared plus the quantity 3 minus negative 2 squared, which equals the square root of 9 plus 25, which equals the square root of 34. Next, look at line segment BD. BD equals the square root of the quantity 2 minus negative 3 squared plus the quantity 2 minus negative 1 squared, which equals the square root of 25 plus 9, which equals the square root of 34. Because the diagonals are congruent, parallelogram ABCD is either a rectangle or square. Find the side lengths of adjacent sides. So AB equals the square root of the quantity negative 2 minus 2 squared plus the quantity 3 minus 2 squared, which equals the square root of 16 plus 1, which equals the square root of 17. And BC equals the square root of the quantity 2 minus 1 squared plus the quantity 2 minus negative 2 squared, which equals the square root of 1 plus 16, which equals the square root of 17. Because two adjacent sides are congruent, parallelogram ABCD is a square. So parallelogram ABCD is a rectangle, a square, and a rhombus.